Hi, I'm Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss the question bank in Module 4. The chapter is Vector Differentiation, and this is Part A, first video. And in this, we will have the questions and we are supposed to solve. These are the old model paper questions, and I want to solve these questions directly now itself. So see the question number 1. Find the angle between the surfaces x square plus y square plus z square is equal to 9 and z is equal to x square plus y square minus 3 at the point 2 minus 1 2. So these are the two surfaces. One is a sphere, another one is some surface. It is the surface. And we have to find the angle between the two surfaces. The angle between the two surfaces is nothing but the angle between its normals. Angle between the two surfaces is nothing but the angle between the two normals. So the two normals. So let us assume that phi 1 is the first surface, which is x square plus y square plus z square minus 9, and phi 2 is the second surface, which is x square plus y square minus z minus 3. Now how to find the normal vector to the surface? So that means you need to calculate, normal means grad phi 1. What is grad phi 1? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the vector of the function x square plus y square plus z square minus 9. This is the grad phi 1. Phi 1 is a scalar point function which is defined as a surface of the sphere whose center at 0, 0, 0 and radius is equal to 3 units. Now what is this I bar into dou by dou x of the entire function, that will give 2x only, plus j bar into dou by dou y of this one 2y plus k bar into dou by dou z of entire function, that is 2z. That is 2 into xi bar plus yj bar plus zk bar. So this is grad phi 1, which indicates that the normal vector to the surface. Normal vector due to the surface phi 1. Now I want to find the normal vector grad phi 1 at the point 2 comma minus 1 comma 2. Grad phi 1, that is the normal vector to the surface at this point. So that is 2 into, this is 2I bar, and replacing x for 2. And y for minus 1 into j bar plus z means 2k bar, that is equal to 4i bar minus 2j bar plus 4k bar, and call this is equation number 1. This is grad phi 1 at this point. Grad phi 1 is the normal vector to the surface at the point 2 comma minus 1 comma 2. Similarly, find grad phi 2. Grad phi 2, I will write here. Now, gradient phi 2, this is the normal vector to the second surface. So, gradient del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function x square plus y square minus z minus 3. This is the function x square plus y square minus z minus 3. So, that is obtained on operating dou by dou x of this entire thing is dou x, I bar plus j bar into dou by dou y of this entire thing 2y plus k bar into, this is minus 1, plus k bar into dou by dou z of this entire thing is only minus 1. So remaining all are zeros. Then it is 2x I bar plus 2y j bar minus k bar. Now I want to calculate, this is the normal vector to the surface phi 2. Normal vector to the surface phi 2. Now, grad phi 2 at the point, what is the point? 2 comma minus 1 comma 2. At 2 comma minus 1 comma 2. So, what it will give? 2 into 2, 4I bar, 2 into minus 1 into j bar, minus 2j bar, minus k bar. X is 2, 2 2s are 4I bar, y minus 1, minus 2j bar, minus k bar. So this is the equation number 2. So grad phi 1 at 2 minus 1 t is the first normal vector, that is n2 bar, and this is n1 bar. The normal vector to the surface, this is n1 bar. Now the angle between the two surfaces is given by cos theta is equal to n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. So it is what is n1 bar? So here we have n1 bar 4I bar minus 2j bar, 4I bar minus 2j bar plus 4k bar, the dot product with 4I bar minus 2j bar minus k bar by magnitude of n bar 16 plus 4 plus 16, 16 plus 4 plus 1. So making dot product 4 4s are 16 plus 4 minus 4 by root 40 into root 21. 16 plus 4, 20, 21. That is equal to 16 by root 40 into 21. Root 40 into 21. So theta is equal to cos inverse of 16 by root 21 into root 40. So on simplifying, you get some value. So theta is the cos inverse of, this is the required angle between the two surfaces. So the angle between the two surfaces is nothing but angle between its normal vectors. This is the first problem. Now go for the second one. Show that the vector x square minus yz into I bar plus y square minus zx into j bar plus z square minus xy into k bar is irrotational, and find its scalar potential function. So given f bar is a vector point function which is x square minus yz I bar plus y square minus zx j bar plus z square minus xy into k bar. This is the given vector point function f bar. Given f bar is irrotational. Irrotational means what? Curl f bar is equal to 0 bar. When f bar is irrotational, then curl f bar is equal to 0 bar. So first we have to show that curl f bar is equal to 0 bar or not. So consider curl f bar, that is del cross f bar, that is determinant of I bar, j bar, k bar. So what is the value? X square minus yz. So what del I bar quotient? What is del? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of x square minus yz, y square minus zx, z square minus xy. So what is this I bar into dou by dou y of this one? I bar into, I am discarding this column and this row. Dou by dou y of this one, it is minus x minus dou by dou z of this one. Dou by dou z of this one, that is equal to minus of minus plus x minus j bar into dou by dou x of this one, that is minus y, dou by dou z of this one plus y plus k bar into dou by dou x of this one minus z minus dou by dou y of this one plus z. So clearly 0 into I bar, 0 into j bar plus 0 into k bar, that is equal to 0 bar. Therefore, what is our conclusion? Therefore, f bar is irrotational vector. That is the first part of the problem. Show that it is the irrotational vector. And also find its scalar potential. That I will tell you. Suppose if F bar is an irrotational vector, then there exists a scalar potential phi such that F bar is equal to grad phi. That is, one theorem is there. If F bar is an irrotational vector, then there exists a scalar potential phi such that F bar is equal to grad phi. Now what is F bar? That is, F bar means x square minus yz into I bar plus y square minus zx into j bar plus z square minus xy into k bar is equal to grad phi. What is grad phi? I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So what is our aim? We have to find phi value, scalar potential function. That is, he asked in the question. We have to find phi. So we have from the above equations, we have from the above relation, from the above, dou phi by dou x. What is dou phi by dou x? X square minus yz. And dou phi by dou y. That is y square minus zx. And dou phi by dou z. That is z square minus xy. Z square minus xy. Then by total derivative formula, by total differentiation, d phi is equal to dou phi by dou x into dx plus dou phi by dou y into dy plus dou phi by dou z into dz. Our aim is to find phi. Phi means integral d phi. If you calculate d phi, then you can find phi in integrating d phi. So that is our aim. By total differentiation formula, d phi is equal to this one. So d phi is equal to d phi by dou x, x square minus yz dx. That is the first term. Dou phi by dou y square minus zx into dy plus dou phi by dou z, z square minus xy of dz. Or I can rewrite this as x square dx plus y square dy plus z square dz minus of yz dx plus zx dy plus xy dz. That is x square dx plus y square dy plus z square dz minus of dxyz, the whole thing, yz dx plus zx dy plus xy dz, the whole thing can be written as d of xyz. This is a d phi. Now on integrating both sides, integral d phi is equal to integral x square dx, that is first term, integral y square dy, integral dz square dz minus integral d of xyz, minus integral d of xyz. That is, what is the value? Phi is equal to x square dx integration x cube by 3, y square dx y cube by 3 plus z square dz z cube by 3 minus of xyz, and which is the scalar potential with respect to f bar, where f bar is the irrotational vector. So this is asked in the question. Find the scalar potential. The scalar potential is phi, and which is obtained as x cube by 3 plus y cube by 3 plus z cube by 3 minus d of xyz integration, that is xyz, which is the required solution for the given problem. Right. So first question comes under angle between the two surfaces, and second question is showing that the vector is irrotational and also finding of scalar potential. Now we have identity, inequality. So equality, grad r power n, prove that it is one result. Grad r power n is equal to n into r power n minus 2 into r bar. So very simple result. So by default, what is r bar? R bar is the position vector, that is, we have r bar is equal to xi bar plus yj bar plus zk bar. And r is equal to magnitude of r bar, that is square root of x square plus y square plus z square. Then dou r by dou x, the partial derivative of r with respect to x. That is 1 by 2 root of x square plus y square plus z square into x square derivative, that is 2x. Or I can write this is equal to x by r, not r bar. R bar is r bar relation, is r is equal to magnitude of r bar. Similarly, dou r by dou y, what you will get? Y by r. And dou r by dou z, that is z by r. So these are the common for this, for the same relation r bar xi bar plus yj bar plus zk bar, you will get the same values. Now what I have to consider is grad r power n. Grad means what? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of r power n. That is I bar into dou by dou x of r power n summation. I can write, instead of writing all the three terms, I am writing only one term, that is I term. That is summation I bar into dou by dou x of r power n. So just to see this, and expanding n into r power n minus 1 into dou r by dou x. N into r is a function of x, y, z. So you will get dou r by dou x also. Summation I bar into n into r power n minus 1 into dou r by dou x, that is x by r. Dou r by dou x is x by r. Or I can write it as sigma I bar into n into x into r power n minus 2. So in expanding, what you will get? I into I bar, n into I bar into x I bar. I will write here. I will write it as n is constant, summation x I bar r power n minus 2. So I am writing r power n minus 2. I will write, what I am writing is summation on expanding the sigma. We get x I bar into r power n minus 2 plus yj bar into r power n minus 2 plus zk bar into r power n minus 2. So what I can take out, r power n minus 2, r power n minus 2, those terms are common. R power n minus 2 into xy bar plus yj bar plus zk bar. But what is xi bar plus yj bar plus zk bar? That is n into r power n minus 2 into this whole thing is r bar, that is equal to grad r power n. So what is the value? Grad r power n is equal to n into r power n minus 2 into r bar. That is the result. N into r power n minus 2 into r bar. That is the required result. This is the operation on f of r with the nabla. Del is nothing but, what is del? Del is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, which we call it as the differential operator, vector differential operator. Right. Now find grad f of r. Grad f of r, that means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of f of r. So I'm differentiating, what you will get? Dou by dou x of f of r, derivative f dash of r into dou r by dou x, first term, plus j bar into dou by dou y of f of r, again f dash of r into dou r by dou y, plus k bar into f dash of r into dou r by dou z. But what is dou r by dou x? X by r. Dou r by dou y by r. Dou r by dou z, z by r. I bar into f dash of r into x by r. Already we have seen in the previous this problem. So that I will show. I bar, that will be used commonly. I bar, what is dou r by dou x? X by r. Dou r by dou y by r. Dou r by dou z, z by r. So I am using the same thing. Dou r by dou x by r plus j bar into f dash of r into y by r plus k bar into f dash of r into z by r. So what are the common factors here? F dash of r is common. It is in all the terms. And again, by r also common term. So I'm taking out, you'll get xi bar plus yj bar plus zk bar. Then what is xi bar plus yj bar plus zk bar? This is r bar. So f dash of r by r into r bar. This is the grad f of r value. F dash of r by r into r bar. So in this case, we use the same thing. R bar is equal to xi bar plus yj bar plus zk bar, and r is equal to magnitude of r bar, that is root of x square plus y square plus z square, and dou r by dou x is x by r, dou r by dou y is y by r, and dou r by dou z is equal to z by r. So using these formulas or results, I use it to do this, and finally the answer is f dash of r by r into r bar, where r bar is xi bar plus yj bar plus zk bar. So these are the problems which we are having under question bank module number 4 in vector differentiation. And this is the reference is the question bank of the course differential equations and vector calculus BT 23 published by IARE. And these are the some of the questions. I will come with another type of questions in part A of module 4. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.